Hello viewers, let's take a look at another jam likely question we have on the board tonight. Come closer. If 10.8 gram of silver calorimeter connected in series with a copper calorimeter, the volume of oxygen liberated is what? We don't know it. So guys, if we are given a question like this, I have mentioned earlier in some of my videos that as far as DAB is concerned, the moment you come across any question given to you, you should be able to tell the topics at which that question fall under. So for this kind of a question now, this question fall under electrolysis. Are you with me? This kind of question fall under electrolysis and second law of Faraday's, to be precise. And how can you solve this kind of a question? One thing you need to know is that they said the volume of oxygen liberated is what? You don't have any issue with copper in as much as you were not asked to look for the volume of copper. So come closer. The first thing you need to do is you have to write out the ionic equation of silver and oxygen respectively. And the symbol for silver is Ag plus E. We have this. And for oxygen, we have this minus 2 times 2 is what? 4. 4e electron. We have oxygen gas. So this will give us plus 4e electron. So with this now, we can say these 2 moles of oxygen liberate what? 4 Faradays. But that is not the case. And not one thing, that the moment you have the ionic equation of oxygen respectively, the next thing is for you to identify the mass of silver deposited and equivalent mass of silver deposited. So come closer guys. Mass of silver deposited is equal to this. We have 10.8 gram. Then equivalent mass of silver is equal to what we have here as the relative molecular mass, which is this gram per mole. And the next one, mass of oxygen deposited, it is what we are asked to calculate for. We don't know the mass of oxygen deposited here, and without you knowing the mass of oxygen deposited here, you can't calculate for the volume of oxygen liberated. So guys, equivalent mass of oxygen is what? We're having 16 times 2. This will give us what? 32. But the moles of oxygen is what? 4. So moles of oxygen is what? 4 for this. So that will give us 32 divided by 4. So let's check. 32 divided by 4. We have 8 gram per mole. This will serve as the equivalent mass of oxygen. So guys, for the fact that we know the mass of silver deposited, equivalent mass of silver, the mass of oxygen deposited, we don't know it. Equivalent mass of oxygen is what? 8 gram per mole. So guys, come closer now. We can say we have mass of Ag over mass of oxygen gas is equal to equivalent mass of Ag over equivalent mass of oxygen gas. So guys, the mass of Ag is 10.8. Equivalent mass of Ag is equal to 108. Mass of mass of oxygen deposited, we don't know it. Equivalent mass of oxygen gas is what? 8 gram per mole. This cancel this. So let's cross multiply. So the moment you cross multiply, we can say mass of oxygen multiplied by 108 equal to 10.8 multiplied by 8 over, we have 108 here, 108, this we cancel this. So guys, 10.8 times 8 will give us 86.4 is equal to divided by 108. We have 0.8 gram of oxygen deposited. So for the fact that we know that the mass of oxygen deposited is given to be 0.8 gram. So guys, now we can easily say volume, we can even say the volume is equal to mass over molar mass. Since we have introduced the volume, let's go back to the molar volume at STP is what? 22.4 dm³. Guys, we are asked to look for the volume of oxygen liberated. So guys, what is the mass of oxygen? Molar mass of oxygen. So that will give us 0.8 of what we have here. The mass of oxygen liberated is 0.8. The molar mass of oxygen gas is what? 32 multiplied by 22.4 dm³ over 1. So guys, you multiply the numerator together, then you divide by the denominator. So 0.8 multiplied by 22.4, we have 17.92 divided by 32 divided by 32. So we have 0.56 dm³. So guys, come closer now. According to the option given to us, we have 4 different options. The first one is 0.56 dm³, B 5.60 dm³, option C 11.20 dm³, option D 22.40 dm³. If you observe vividly, this is equivalent to the molar volume at STP. If you should divide this with 2, we have 11.20 dm³. So option C and D is out of it. Rather, the option is option A. The option is what? Option A, this. Mind you, as far as electrolysis is concerned, when we talk about the first law of Faraday's and the second law of Faraday's, if you come across any question as far as second Faraday law of electricity is concerned, this is the steps by steps of how you can easily deduce the answer. As a Jambite out there or WAEC student out there, if you have any question, do what to drop it in the comment box. Chemistry Core is there to give you the best solution to any problem you have. Thanks.